All right, let's look at the scalar product of vectors. All right, let's say you have two vectors, vector u, which has components u1, comma u2, and vector v, which has a components v1, comma v2. All right, so the scalar product, sometimes it's called the dot product, right? Dot, or also inner product. Right, dot product, right? Right, so let's say you want to do vector u dot product with vector v. This is defined as u1 times v1. So you multiply components together and then add them up. u2 times v2. That's how we defined. Right, then we can express the length of a vector using inner product. So length of the vector, just like you can use the distance formula. So let's say if you want to find the norm of vector v, is simply square root of, right, first component squared plus second component squared. Right, which is exactly the same thing as you will notice that the v1 squared plus v2 squared can be expressed as v1 dotted with itself. So you can write it as a square root of vector v dotted with itself. Right, so this is called the norm of a vector, which can be also written in terms of the dot product. Right. Here are some properties of dot product. Commutative. You can easily check that u dot v is going to give you exactly the same thing as v dot u, right? Because this is going to, you can just flip u1 and v1 and switch u2 and v2. You're going to get the same thing, right? Associative. Let's say you have a constant a times, excuse me, u dot v. We can do this a times u first, then do the dot product, which is the same thing as a. You can just do u dot v first, then multiply by a, and you can actually place a anywhere you want. So you can do u times a v. It's going to be all three are the same thing, right? And it's also a distributive. So let's say if you have, let's say, u dot product with v plus third one, so I'll just say vector w, right? Then you can distribute u dot to each term. So you can get u dot v plus u dot w. Right, so it is distributive also. All right, so those are the three properties of scalar product, and we can express the norm of the vector using inner product or dot product. And dot product, the definition is just a component-wise multiplication, then add them all up. All right, that's it. I hope that this was clear.